Okay, I'm looking at a revision quiz for Unit 4 Maths Methods. So the first question on the quiz we have is y equals ln x plus 1 on x, and we need to find the coordinates of the point or points of inflection. So to identify our points of inflection, we're looking when our second derivative is equal to 0. So I'll need to do my first derivative first. To make this a little bit easier on myself, I'm going to rewrite this as ln x plus x to the negative 1 instead of 1 over x. So then when I do my y dash, my first derivative, my ln x, the derivative of that is 1 over x. And then when I do the derivative here, I'm bringing down that negative 1 and I'm making that x to the negative 2. So when I do my second derivative, I'm going to do the same thing first to make this x to the negative 1. And then I'm going to do my second derivative, so my double dash. So I would get negative x to the negative 2 here. And then I would have, that would become a plus, the negative times the negative, plus x to the negative 3. I can then rewrite that as negative 1 on x squared. And I missed my 2 here. I should have had a 2 when I brought that down. Negative 2 times negative 1 gives me my 2 there, 2 over x cubed. So then I'm going to be solving that when the second derivative is equal to 0. So I'll put a 0 here is equal to negative 1 on x squared plus 2 over x cubed. And then I'm going to want to solve what value of x would give that. So I can multiply through by x cubed. 0 times x cubed is just going to give me 0. When I multiply this negative 1 on x squared by x cubed, I'm going to be left with negative x because I would have a negative x cubed on the top and the x squared on the bottom. Then when I multiply this one by x to the power of 3, I would be left with 2. Then I can solve that. I can take that x to the other side, and I would get x is equal to 2. I then want to just confirm that that is an inflection point by checking the concavity before and after. So I'm subbing in numbers either side of 2 into that y double dash to check what that's equal to. So I've got the y double dash is equal to negative 1 on x squared plus 2 on x cubed. If I go and put in a 1 to start with, I would get negative 1 on 1 squared plus 2 over 1 cubed. Now, negative 1 on 1 squared is just going to be negative 1, and 2 on 1 cubed is just going to be equal to 2. So then that gives me negative 1 plus 2 is equal to 1. And if I get a positive number, that means that is concave up. I'll then check on the other side of the 2 and look at y double dash of 3. And when I put that in, I'm going to get negative 1 over 3 squared plus 2 over 3 cubed. So I get negative 1 on 9 plus 2 on 27. So then I need to add those together. Obviously our 1 over 9, we'll change that to something over 27 because this is a tech-free question. So that would be negative 3 on 27 plus 2 on 27. So then negative 3 plus 2 is going to give me negative 1 on 27. The main part of this is to see it's a negative answer, so then that's concave down, and then that confirms that I have a change of concavity there, which is my point of inflection. The last bit is that I need the coordinates of that, so I'm going to need to sub in my x equals 2 back into that original equation. So to get my y value, I'm going to need ln of 2, because I've got ln x, and my x is 2, plus 1 on 2. And this being a tech-free question, I would just leave that as the answer there.